Hello, good evening everyone. Welcome to BYJU'S exam prep. So, yes, so audio and video are absolutely fine, I guess. And I hope that all of you have enjoyed the yesterday session. And today I'm going to continue the session on communication system, part 2, especially based on the digital communication, and one or two questions from the analog communication as well. Because yesterday, from my question bank, I was left with some questions, and the time was up, so that's why we couldn't continue it. So first of all, just share the session with all of your friends and like the session, guys. Quickly share the session with all of your friends, because until and unless you come live to the session, there will be no enjoyment in the session. Because when you see the other people solving the questions and suppose you are not able to solve, then you will realize that this is the time when you have to be you have to be serious on your preparation. ठीक है, तो यहाँ पे आपको बहुत ज्यादा जरूरत है कि आप सीरियसली प्रिपेयर करो अपने और एग्जाम के लिए, और सारे स्टूडेंट्स को भी कलेक्ट करके लेके आओ, ताकि आप समझ पाओ कि आपके फ्रेंड्स कैसे परफॉर्म कर रहे हैं और आप कैसे परफॉर्म कर रहे हो, आपको और कितने प्रिपरेशन की जरूरत है ना। तो इसलिए इम्पोर्टेंट है लाइव सेशन, जब ज्यादा से ज्यादा स्टूडेंट्स ज्वाइन करते हैं तो वी गेट सम benefit also, and we get some competitive environment also. So I am sharing this session in my groups, so you also share in your groups, so that the all students, those who are willing to solve the questions of the communication, can come and join this session. Okay. So already number of students are joining quickly. Very good. So I have shared. I hope that the number of students will come very fast. Yes. So before starting the session, let me introduce myself. So this is Saket Verma, and I have done MTech from IIT Guwahati. I'm having more than 13-year experience in the field of GATE and ESE, and I have cracked a different PSU exam as well. So my area of expertise are this one: electromagnetic theory, communication system, advanced communication system, signals and system, and ICT. These are the area of expertise where you can find the interest with me, where you can go learn the concepts here with me. So next is my Telegram group. So this Telegram group, you can come in this Telegram group where you can get this daily dose to improvement and questions, also notification of the class and important PDF and notes, etc. And the UPSC ESE 2023 mains results are out, and you can share your result with us. And there is a scholarship test for all the students who are going to prepare for the Gate 24 or Gate 25. They can give the scholarship test that is on Sunday from the 9 a.m. to 9 p.m. The window will be open. You can register yourself. The link is given in the description, and the workshop also there for all of you. So you can join in the workshop as well. and the workshop will be taken by the Richa ma'am, and she is having more than 5 year experience. And this is the first questions. Yes, this is the first question, and I'm setting the timer for all of you. So let's see how many of you will be able to solve this question. I'm giving you 3 minutes because it is a quite lengthy question to read, not to solve, but it is quite lengthy to read, but the solution will not be that tough. So consider a digital communication system that uses a repetition code for the channel encoding decoding. In particular, each transmission is repeated n times, where n is 2 to the power n plus 1 is an odd integer, and the decoder operates as follows. If n block of n received bits the used of the number of the 0 exceeds the number of ones, then the decoder decides in favor of 0. This is the type of question we you might have seen. So how do you calculate the error if the probability p is 0.2? Yes, last 1 minute. Last 20 seconds. Yes, so let's start this solution for this question. As you can see that here we are transmitting the 5 number of bits because it is a repetition code of the channel encoding and decoding, and we are taking the decision in favor of 1 if more than number of ones are exceeding than the zeros, and if we are taking in the favor of 0 when the number of zeros are exceeding the number of ones. Okay, so here there is a formula to calculate the probability of error. The probability of error you can calculate by this formula: summation I is equal to n plus 1 divided by 2 to n, that is nci, the error probability pi, and 1 minus probability of error n minus I. Okay. Probability of error is n minus I. Let me check once. So if we have I equal n equal to 5, so 5 plus 1 6 divided by 2 is 3, and here we will get up to 5 because n is 5 here. Now this is 5 ci plus I think this is p to the power 5 minus I. It should be 5 minus I here, and this p to the power I. Change this one, and we will understand obviously what. So this is I. When I equal to 3, you will put, so out of 5 bits, 3 bits are in error. So p to the power 5 minus 3, that is 2, and wait, this is 1 minus p. No? This is 1 minus p to the power I. So here we will get 1 minus p to the power 3 plus, when there are 4 bit in error, so p to the power 4 bit in error. Error probability is 4 should be there. Yes, it should be the reverse one only. Out of 5, 4 bits are in error. Out of 5, the 3 bits in error minus I, because there is no error. So it should be I, and it should be n minus I. So it should be 3. Out of 5 bits, 3 bits are in error, and then 2 bits are not in error. So, and 4 bits are in error, and then 1 minus p to the power 1, and then out of 5, all the 5 bits are in error, and no bits are in error, like this. Okay, so this is nothing but the 5 factorial divided by factorial 3. Okay, and this is factorial 2. So p to the power 3, 1 minus p whole square, and 5 factorial, 4 factorial, 1 factorial, p to the power 4, 1 minus p, and 5 the 5 is 5 factorial, 0 factorial, again 5 factorial, p to the power 5 into 1. So from here what we will get? This is 5 4, so you will get 10 only. Okay, so this is 10 p to the power 3, 1 minus p square plus 5 p to the power 4, 1 minus p, and this is p to the power 5. Okay, so here the probability is how much? The p value of probability here is 0.2. So 0.2. So this is 0.2 whole cube. 1 minus 0.2, that is 0.8 whole square, plus 5 into 0.2 to the power 4, and 1 minus 0.2, that is 0.8, and then 0.2 to the power 5. Let's see what we are getting here. So 0.05792. This is what I am getting, and up to decimal 2 decimal 0.05 would be the answer. So answer for this is 0.0. Okay, now solve the next question. Solve this question, very interesting, easy and logical also. But if you know the concepts, then you will be able to solve it. Otherwise, you will face difficulty in looking into this question, that you may find that it is quite difficult. Read the question properly. Last 40 seconds. Okay. So you got the answer? See, in this graph, what is given? First of all, let's understand the question. Why you do 3 to 5? 3 to 5. Yes, answer is option number C. Option number C. 3 to 5. 3 to 5 because and if you get the error only if 3 bits are in error out of 5 bits, that the question says. If you don't have any idea about this question, just let me tell you that if you are transmitting 0, if you want to transmit 0, you are transmitting the 5 zeros. Okay, and according to the question says when the number of zeros are more than the number of ones, then only you will take the decision in favor of 0. So here you will take the decision in favor of 0. decision in favor of 0. Okay. So because here the number of zeros are more, so you will take decision in favor of 0. Suppose this type of situation comes, then the number of ones are greater than number of zeros, so you will take the decision in favor of 1. In favor of 1. So you are transmitting the bit 0, but you are taking the decision in favor of 1. That means it is an error. So more than 3 bits are 1, then you will take the decision in favor of 1. If suppose 3 bits are 1, then also you will take decision in favor of 1. So 3 bits, minimum 3 bits, and maximum all the 5 bits can be 1. Then you will take decision in favor of 1. So that is error. ठीक है, तो वो एरर हो जाएगा। अगर आप 3 बिट या 3 बिट से ज्यादा 1 ऑकर करते हो, कब? जब आप 5 0 ट्रांसमिट कर रहे हो। और 5 0 क्यों ट्रांसमिट कर रहे हैं, क्वेश्चन में बोल रहा है ना। देखो, a carrier wave of frequency 100 megahertz is frequency modulated by sinusoidal wave of amplitude 20 volts and frequency 100 kilohertz. The frequency sensitivity is this one. ठीक है, तो यहाँ पे देखते हैं हमारे पास मॉड्यूलेशन इंडेक्स का ग्राफ दिया हुआ था। तो बीटा इज इक्वल टू होता है फ्रीक्वेंसी डेविएशन डिवाइडेड बाय मैसेज सिग्नल फ्रीक्वेंसी। ओके, ये भी मैक्सिमम फ्रीक्वेंसी डेविएशन होता है। फिर यहाँ पे आ गया के एफ इंटू ए एम डिवाइडेड बाई एफ एम। सो व्हाट इज के एफ? के एफ इज 25। व्हाट इज द मैसेज सिग्नल एम्पलीट्यूड? मैसेज सिग्नल एम्पलीट्यूड इज 20। मैसेज सिग्नल फ्रीक्वेंसी इज 100। ठीक है, 25 किलोहर्ट्ज था, 100 भी किलोहर्ट्ज था। ठीक है, तो यहां से आ जाएगा तुम्हारे पास 5। तो बीटा की वैल्यू 5 आ रही है। अब इस ग्राफ में देखो, बीटा की वैल्यू 5 है, तो आपको एक ग्राफ में यहाँ पे दिया हुआ है कि डेल बीटा टी यानी ट्रांसमिशन बैंडविड्थ बीटी है ना, बैंडविड्थ बाय ट्रांसमिटिंग ओनली बीटी अपॉन डेल्टा एफ इज 3। तो आपको गिवन है बीटा टी अपॉन डेल्टा एफ इक्वल टू 3। ठीक है, तो यहां से हमारे पास बीटा टी इज इक्वल टू कितना आ जाएगा? 3 डेल्टा एफ। Okay, so we want to calculate the bandwidth only, bandwidth by transmitting only those sidebands whose amplitude exceeds 1% of unmodulated carrier amplitude is equal to। ठीक है, तो यहाँ से हमारे पास आ जाएगा के एफ की वैल्यू 25 है, एम्पलीट्यूड 20 है। यहाँ पे आ गया 3 इंटू 25 इंटू एम्पलीट्यूड तो 20 है ही, 150 इंटू 10⁻³ ठीक है, 150 इंटू 10⁻³। यहाँ पे आपको जो रेशियो दिया हुआ था उसको चेक कर लो। रेशियो आपको तो दिया यहाँ से, तो हमारा 1.1% ऑफ अनमॉड्यूलेटेड कैरियर बोल रहा है, तो 1% मतलब आप इसको यहाँ से ऐड भी कर लोगे तो यहाँ कितना आ जाएगा? ये 1.51% मतलब और 100 इसमें आप ऐड कर लो तो ये आ जाएगा 1.1 मेगाहर्ट्ज। ठीक है, क्योंकि 1% बोला था तो बी टी इज इक्वल टू 1%। तो 1% ऑफ बी टी, तो 1% ऑफ बी टी जब आप कैलकुलेट करोगे तो इसमें हम मल्टीप्लाई बाय 100 भी कर रहे हैं, है ना। बी टी इज इक्वल टू दिस, ये 1% ऑफ बी टी है। ठीक है, 1% ऑफ बी टी, यहाँ पे मैं इसको प्रॉपर लिख देता हूँ, ये आ गया 1% ऑफ बी टी इज दिस। सो बी टी इज इक्वल टू 100 इंटू 150 इंटू 10⁻³। सो टोटल आ जाएगा। नहीं, आपको ग्राफ में एक्चुअली दिया हुआ था इसीलिए हम लोग उससे नहीं निकाल सकते, है ना। इसमें आप ग्राफ डायरेक्टली 2 इंटू बीटा प्लस 1 इंटू एफ एम इसलिए नहीं कर सकते हो। 1.2 आपका आ जाएगा, 1.2 किलो हर्ट्ज के अराउंड आ जाएगा। ठीक है, 1.2 किलो हर्ट्ज आ जाएगा, जबकि आपको ऑप्शन में देखो सारे क्या दिए हैं, मेगा हर्ट्ज में दिए हैं। तो आप लोग 1.2 मेगा हर्ट्ज तक कैसे पहुंच रहे हो? और ये आपको जो क्वेश्चन में जो सेकंड लाइन लिखा हुआ है ना, वो बहुत इंपॉर्टेंट है यहाँ पे, और ये ग्राफ दिया हुआ है तो वो भी बहुत इंपॉर्टेंट है। तो बैंडविड्थ बाय ट्रांसमिटिंग ओनली दो साइड बैंड फ्रीक्वेंसी हुज एम्पलीट्यूड एक्सीड 1% ऑफ द अनमॉड्यूलेटेड कैरियर। तो इस तरीके से हम लोग इसको सॉल्व करेंगे। ठीक है, चलो इसको सॉल्व करो। हाय, हेलो। Last 10 seconds. Anyone? No one? Okay, see, the let x and y be the independent random variable both having zero mean and variance sigma square. So if any random variable is having the mean zero, what does it signifies? That suppose the variance is sigma square, then we know that this is the mean square value minus mean whole square. Okay, so whenever the mean is 0, so if the mean is 0, then the variance is equal to mean square value. So this thing you should know. And this is Vt and Wt, and we want to calculate the RVW, that is the cross correlation, right? So RVW or omega T1 comma T2 is nothing but expected value of V of T1 and W of T2. So expected value of Vt is x cos omega naught t plus y sin omega naught t, x cos omega naught t plus y sin omega naught t, and then Wt2 is y cos omega naught t2. So y cos omega naught t2 minus x sin omega naught t2. Okay. Now, when we will multiply, we will get omega naught t1, omega naught t1, x and y cos omega naught t1 cos omega naught t2 minus x square sin cos omega naught t1 and sin omega naught t2. Okay, then plus y square sin omega naught t1 and cos omega naught t2, then minus x into y sin omega naught t1 and sin omega naught t2. Okay, so you're getting this? Since the x and y are independent, we can write expected value of xy. This is the omega naught t1, omega naught t2. Xy is common in both. In this two, suppose if I want to write this expected value of xy, we can write this cos omega naught t1 and cos omega naught t2 minus sin omega naught t1 and sin omega naught t2. Okay, right. Let's write this term together, and similarly we can write this minus x square expected value of cos omega naught t1 and sin omega naught t2 and plus y square expected value of sin omega naught t1 cos omega naught t2. So expected value of xy, because as I told you that this x and y are independent, we can write expected value of xy as expected value of x multiplied with expected value of y, because these are the constant terms and this is expected value of x of y. So we can take it separate, and expected value of x is 0 because the mean is 0. Here it is given that 0 is mean. So 0 mean, that means we will get these two terms 0. So this is 0. And here we will get minus sigma square expected value of cos of omega naught t1 and sine of omega naught t2 plus sigma square, because this mean square value you will get expected value of sine of omega naught t1. This is actually expectation inside. This is inside. This expectation is inside. Omega naught t2. Now, what will be the question? So, sigma square we can take common, and here also, here we can take the sigma square common, and we will get this as a constant, and you will get sine A plus B. Yeah? So, we will get sine A minus B, that is omega naught t1 minus t2. Sine omega naught t1 minus t2, and divided by 2 will definitely come, because from here when we apply, this is the 2 cos A 2. Why we should get 2? Yeah, sigma is square only, na? So there is a option. Yeah, option D is there. Sigma is square only. Sigma is square. Okay, so this is the sigma is square sine omega naught T1 minus T2. Got it? Okay, now answer this question. Last 1 minute. C and D you are getting. Now this time, think of it. The power is spectral density. Okay. Yes. Now you got the right answer. A and D both are correct. A and D both are correct. Got it, Anand? Anand? A and D both are right. This is an MSQ question. Yes. So let's move forward because you have already got this. If anyone having any doubt in the previous question, just comment in the comment section. कि किसी को भी डाउट है अगर लास्ट वाले क्वेश्चन में तो बताओ, उसको फिर एक्सप्लेन करूंगा. RMS value, RMS value not clear. Bhanu, RMS value. Solve this question, then I will tell you. Calculate that tau tends to infinity and tau tends to 0. RMS value you will get total power minus DC power. Variance only you need to calculate. The average power you will calculate, you will get 25, right? And the mean you will get tau tends to infinity, so the Gaussian function will be 0. So you will get mean whole square is equal to 9. So mean is 3. So 25 minus 9, you will get 16. That is the AC power. And root mean is square value. It is asking for RMS. So root over, that means standard deviation. So root over 16. Got it? Given that the message signal is sine 200 pi t, frequency sensitivity and the phase sensitivity is given the difference in the bandwidth of the frequency modulation and the phase modulation. What is the answer? 198. 198. 198 is not correct. Is not correct. Okay, so for frequency modulation, first of all, let's calculate the bandwidth. So for calculation of the bandwidth, we will calculate the maximum frequency deviation. That is your KF into AM. No, 990 is also not correct. KF is radian per volt. It is given in the radian per volt, guys. So important thing that first of all you convert it into the KF. So this is 20, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Pi divided by 2 pi. So you will get 1, 2, 3, 10 to the power 5 only. Okay, or you can say 100 kilohertz. In kilohertz we want to calculate, so 100 kilohertz. So what is the bandwidth? Bandwidth is 2 times of 100 kilohertz plus message signal frequency is, I think there is a calculation mistake or something. 100 kilohertz is correct. This is 1 kilohertz. If, actually it is 2000 pi, I guess. Yes, there is a mistake in the typing. This is 2000. This is 2000 pi ti. So the message signal is 1 kilohertz. Message signal is 1 kilohertz. So this is 1. 101 into 2, 202 kilohertz. Yes, maybe your answer might be correct because of this 1 kilohertz you might be getting this answer. But there is a printing mistake for PM. This is KP into AM into FM. Okay, then what is the KP? 10. AM 1. FM 1. So it is 10 kilohertz. So bandwidth is 2 times 10 plus 1 into 2. So 22 kilohertz we are getting. So the difference in the bandwidth of FM to PM is 202 minus 22 is 180. So answer is 180 kilohertz. Answer is 180 kilohertz. Next question. Forty 40 seconds. Very basic concept. Very basic concept. Consider an AWGN channel with the bandwidth of 1 kilohertz and the noise power spectral density N0, the minimum signal power required for the reliable information transmission at 10 kbps. So we know that, right, for error-free transmission, it is asking for the reliable communication means error-free transmission. Okay, for error-free transmission, the channel capacity should be greater than equal to the bit rate. Okay, the channel capacity should be greater than equal to the bit rate. So the bit rate is given. So we know that this B log base 2 1 plus signal to noise ratio should be greater than equal to 10 kbps. The bandwidth is 1 kilohertz. So this is also cancelling. So 1 into 10 to the power 3 log base 2 1 plus signal to noise ratio. So it will get cancelled. We will get 2 to the power 10. Okay, 2 to the power 10 less than 1 plus signal to noise ratio. So we will say 2 to the power 10 minus 1 should be less than equal to signal power. This is S means signal power, the minimum signal power required na, divided by noise power. So this is 1023 only. So the signal power S should be greater than or equal to 1023 into the noise power. How do you calculate the noise power? This is the noise value of the noise spectral density and the bandwidth is 1 kilohertz. So we will take this as a this one. The channel bandwidth we consider as a low pass channel 1K. So 1K and this is N naught. This is in kilohertz. So we will take 2 kilohertz. So 2 into 10 to the power 3. So what is this value? N naught into B only. Okay. N naught into B we will take. Because I remember we calculate it by the N naught eta B only, right? So in the formula only we have eta B. So let's not write 2 because they are not writing as a filter. So just take it as eta into B. Because actually, how do we take this? This is N naught into B, one-sided spectrum, and if I take it in two-sided, so in this two-sided spectrum, we have N naught by 2. So in the N naught by 2 and this is minus B to B, so when you will take it, you will get N naught by 2 into 2B. So ultimately you will get N naught into B only. So no need to take that. Okay, so 1.023. So in the milliwatt we want to calculate. So this is 1023 milliwatt. Signal power is 1023. How many of you getting 1023? Okay, now coming to the next one. Yes, guys, before going into the next question, let me tell you about the BYJU'S exam prep app because the app is very exciting, very wonderful. And here, if you participate in the quiz, which I am going to take today at 5:30. So at 5:30 p.m. I am going to take the quiz session, and in this quiz session, I am going to take the questions of the network theorem. So if you want to solve the questions of the network theorem live, then join the BYJU'S exam prep app and you will see the leaderboard also. Here you will see the leaderboard and in this leaderboard you will get the ranking. When the number of questions you will solve, you will get the ranking also. So this is the one more question for you. What is the answer you are getting? So answer is B. Okay, answer is B only, and you have to calculate the probability of different messages, that is A B A B B B A, like that. It is given A B A A B B A, and the probability you have to multiply in F D D D F D F, the amount of information it is asking, it is asking in the Hartley. So convert it into Hartley and in the bit. Okay, so answer is B. This answer is in B. So just multiply all the probabilities given here and take the inverse of that probability. And in the natural log, when you will take in the natural log, and you hardly when you will get the 10 log. So log base 10, 1 upon probability of A B A B B A, and similarly log base E, 1 upon probability of F D D F D F. You will get the answer. Okay. So thank you for watching this session, guys, and don't forget to join our crash course. And for this, you can call in this number and get the detail of our crash course. And the crash course will be for Gate 24. This is for EC and EE students both. And this is my Telegram group, so don't miss this Telegram group also. Just this is the link of the Telegram group, and the name of the Telegram group is Electronic by Sakit. Thank you.